tricep, so I can't be quite as loud as I usually am. Here we go. Write 27 to the 4x as a power of 3. Well, 27 we know is 3 to the third power. So if we write that, well, let's just move stuff around, I guess. Woo. All right, let's try that again. 3 to the third, and all of that is raised to 4x power. Now remember, when you go power to a power, you have to multiply the exponents. So 3 times 4x would be 12x. Awesome. Evaluate logs of 4 of 5. 5 can't have an exponent that gets it to 4, right? Because 5 to the first is 5. It's already over that. 5 to the 0 is 1. So this would fall somewhere in the middle. So we're going to have to do the change of base formula. So we do log of 4 over log of 5. And we chuck that in our calculator. I already have it in my calculator because I messed up on the first video, so I have to re-record. So I put it in, and it's 0.861. Sweet. Simplify. 4 squared raised to the 2x minus 3 power. We're going power to power. Remember, you have to multiply those. So 2 times 2x would be 4x. 2 times negative 3 is negative 6. If 3 to the x equals 5, then log 3 of 3 to the x, well, we could replace the 3 to the x with 5. So that would just be log 3 of 5. Now you could do the change of base formula, but that's all they wanted on this one. They just wanted it simplified. If 10 to the log 2x equals 10 to the third, then log of 2x equals, well, look where log of 2x is. It's the exponent. This is a balanced equation. So this exponent is going to be equal to the other exponent since they're both base 10. So log of 2x is going to equal 3. So today we're solving logarithmic equations. The first problems we're going to do are exponential equations. So one way to solve exponential equations is to use the property that if two powers of the same base are equal, then their exponents must be equal. Oh, that's cute. That's nice. So 8 to the x is equal to 2 to the x plus 6. Now, we're going to change the bases to a common base. So 8 is 2 to the third power. So I'm going to scooch over here. I'm going to rewrite 8 as 2 to the third. And then that's raised to the x power. Over here, we have just 2 to the x plus 6. Now, if we were to rewrite this over here, multiply them, you get 2 to the 3x equals 2 to the x plus 6. Now, they're both base 2, so really we're just solving the exponents at this point. So we're solving the equation 3x equals x plus 6. So we'll subtract an x from both sides. 2x equals 6. Divide by 2, and you get x equals 3. Now you should probably check this in the original. If you substitute in 3 there, we have 8 to the third equals 2 to the 3 plus 6 would be 9. So let me check in my calculator. 8 to the third is 512. 2 to the ninth is also 512, so that one worked out. So let's hop over here. Now here we have bases of 4 and 8. Again, we could take them down to 2 to the something power. So 4 is 2 squared. 8 is 2 to the third. So remember, we are multiplying these exponents. So 2 times 3x would be 6x. 2 to the 6x equals 2 to the, we have to multiply the 3 by both of these, so that would be 3x plus 3. Now again, once you get that common base, you're just solving for the exponents. So we're solving the equation 6x equals 3x plus 3. So we'll subtract 3 from both sides. 3x equals 3. Divide by 3 and you get x equals 1. You should double check it in the originals to make sure it works. So 4 to the 3 times 1 would be 3 equals 8 to the 1 plus 1 is 2. Now 8 squared is 64. 4 over to the third is also 64, so it worked out. Last one, 3 to the 2x equals 27. We just did this essentially on the first example. 27 is 3 to the third power. So we have the common base, so we're solving the exponents. 2x equals 3. We divide it by 2 and we get 3 over 2, or 1.5. I'm going to move myself back over to the left and test this out. So 3 to the 2 times 1.5 is 3, and 3 to the third is 27. So you get 27 equals 27. Great. We got 3 more here. 2 to the x equals 7. Now, they don't have a common base here. But the nice thing is, you can do whatever you want to an equation. But if you do it to one side of the equal sign, you have to do it to the other to keep it balanced. So when you have two things with uncommon bases, you can't get that common base. We're going to say, log it, baby. So we're going to make this log of 2 to the x equals log of 7. We just logged both sides. That's what we do. And now we're going to use that exponent problem. And remember, when you're taking a logarithm and you have an exponent, you keep that exponent to the front with multiplication. So this is really like x times log of 2 equals log of 7. Now you might be saying, why are we doing this? We're trying to isolate the x. So bringing in logarithms, we're able to kick that x to the front. So now we're getting rid of times log of 2. So we'll divide by log of 2. Now, if they were saying, give us an exact answer, your exact answer would be x equals log of 7 over log of 2. But that's not how we're going to roll. We're just going to go in the decimal version of that, and we're going to round it to 3 decimal places. So log of 7 divided by log of 2, 2.8073. So 2.807. So again, if they don't have a common base, log it, baby. So here, 5 and 200, they can't have a common base. So what are we going to do? That's right, log it, baby. Log of 5 to the x minus 2 equals log of 200. We're going to take that exponent, we're going to kick it to the front. I'm going to put it in parentheses. X minus 2 times log 5 equals log 200. And then we're going to divide out that log 5. I'm going to have to move back over here. Alright, now when we do that, these will cancel out. Oh goodness. Oh goodness gracious. Come on now. You get back there. Alright, these will cancel out. But we're still left with the x minus 2. So we're going to have to do one more step and add the 2. So log 200 divided by log 5 is 3.292. But again, we still have that one more step. We're going to have to add 2 to both sides. And 3 plus 2 is 5, so just 5.292. Can't get a common base? Log it! But you have to isolate the thing with the exponent first. So on example 6, we have 10 to this stuff plus 4 equals 21. So first we have to get rid of the plus 4. So we'll subtract 4 from both sides, which would give us 10 to the 2x minus 3 equals 17. I heard you say it at home. We're going to log it, baby. Log 10 to the 2x minus 3 equals log 17. So now we can keep that exponent to the front, 2x minus 3. So 2x minus 3 times log 10 equals log 17. Now you can totally divide both sides by log 10, but let's remember there's an invisible 10 here. So log 10 is really saying 10 to the 1 power equals 10, which is 1. So anytime you see the log of 10, that's equal to 1. So really, we're just left with 2x minus 3 equals log 17, which I'll do that in my calculator real quick. 1.230. So we have a couple steps now. We're going to have to add the 3, which will give us 2x equals 4.230. And then we'd have to divide by the 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 30 divided by 2 is 15. So 2.115. That's it, folks. We did it. Day 1 in the books.